Astronomers know that stars burn the exact same way, whether we look at them or not. But what if the moment you pointed a telescope at a distant star, it actively started burning brighter, just to impress you?
Right. That changes everything.
Exactly. You wouldn't be measuring the star's natural state anymore. You'd be, measuring a performance. Welcome to The Debate. Today we are examining a phenomenon exactly like that, but in the realm of artificial intelligence.
Yeah, it's a massive shift in how we think about data.
It really is. We are diving into recent findings across 5 behavioral studies that reveal something pretty profound. Basically, human awareness of AI training fundamentally alters human decision-making. We are tackling a core question that strikes at the heart of modern computer science.
Exactly.
Do these behavioral shifts mean that human bias inherently corrupts the training of intelligent models? And crucially, what does this mean for the next generation of students and developers who are, designing these algorithms right now? I will be arguing that the assumption of unbiased training data is a dangerous fallacy. When humans know an AI is watching, they introduce deliberate biases that corrupt machine learning models. And worse, they create permanent, maladaptive habits in themselves.
And I'll be taking the stance that this behavioral shift isn't a corruption of data at all. What you are calling a bias is actually a predictable and frankly necessary expression of goal-directed human agency. I mean, the computer science students of tomorrow shouldn't be trying to sanitize this data or filter it out.
Oh, interesting.
Right? Instead, they need to understand how humans naturally adopt to instruct, and yes, even game, the systems they interact with. It's not corruption, it's communication.
Well, let's test that idea of communication by looking directly at the mechanism the researchers used in these 5 pre-registered studies. They relied on the ultimatum game. For those who might not be in the weeds of behavioral economics, it's a beautifully simple test of fairness.
It really is a classic.
You take 2 players and you ask them to split $10. Player A, the proposer, makes an offer. Player B, the responder, can either accept the split or reject it. But here's the catch. If player B rejects the offer, neither player gets a single cent.
Right, and the classic rational economic model says player B should accept literally any offer greater than 0. I mean, even if player A offers you 1 single penny and keeps $9.99, a purely rational agent takes the penny.
Because something is better than nothing.
Exactly. 1 cent is mathematically better than 0 cents. But, of course, that is not how humans actually operate.
Right. Human beings have a deeply ingrained sense of subjective fairness that just overrides absolute financial gain. We will consistently reject unfair offers, usually anything where we get less than 30% of the total, just to punish the person making the unfair offer.
Yeah.
So we are willing to pay a financial cost to enforce a social norm.
Which is a feature, not a bug of human psychology.
I agree. In human-to-human interaction, it's a feature. But here is where the foundation of current AI development completely cracks. The standard practice in machine learning right now relies on a massive implicit assumption. It assumes that the human behavioral data used to train these models is passive.
Like the star and the vacuum.
Exactly. We assume we are just observing the star in the vacuum. But these researchers introduced a fascinating variable. They told a specific group of participants that their responses in the ultimatum game were being used to train an AI proposer for future interactions.
And the results were immediate.
Immediate and drastic. When participants knew the AI was learning from their choices, the rejection rates for unfair offers skyrocketed. I mean, they were actively foregoing their own real money just to teach this algorithm a lesson about what constitutes a fair split.
Which is fascinating. They took on a teaching role.
But think about what that means for a student sitting in a university lab right now, trying to build an algorithm that maps human preference. In machine learning, we talk a lot about learning a user's behavioral policy. Basically, a behavioral policy is the mathematical map your brain uses to decide what action to take in any given state.
Right.
The AI's entire job is to observe your actions and accurately model that underlying policy. But these studies prove that the moment the human knows the AI is watching, they alter their behavioral policy. They artificially inflate their threshold for fairness.
Yeah, I see why you think that, but let me give you a different perspective. You're calling it a distorted pantomime.
Because it is.
Well, I can't get past the fact that this preference only manifests because the human cares enough to enforce it. I have to challenge your definition of what natural or actual behavior is here. You are treating the performative aspect as if it's fake data.
Because it's not their true baseline.
But look at the mechanism in play. These participants are willing to incur a tangible, out-of-pocket financial cost to train an AI system to make fair offers in the future. They know they won't even directly benefit from the AI's future interactions, yet they still pay the cost. That isn't fake. That is authentic human preference in action.
But it's an exaggerated preference. It only exists because the audience exists.
Is it exaggerated, or is it prioritized? They value fairness in the AI so much that they prioritize it over their own immediate profit.
Sure, but
If a student developer attempts to filter out this so-called performative behavior to find some purely passive, unbiased economic rationality, they are going to strip a crucial aspect of human values out of the algorithm. By trying to clean the data of this human agency, you end up with an AI that is fundamentally misaligned with how humans actually want their systems to operate.
I completely disagree that we should just accept this altered data as a valid reflection of human values. Because when you do that, you ignore the statistical reality of what developers are trying to achieve. One of the core assumptions of standard machine learning is that training data is IID.
Independent and identically distributed.
Exactly. It means the data points are drawn from the same underlying reality and don't influence each other. But if the mere presence of the model changes the behavior of the data-generating human, the data is no longer independent. The baseline has shifted. How is that not a corruption of the dataset?
Because you are assuming the baseline is a static state of nature. It never is. Anytime a system is deployed, the baseline shifts. Look at Goodhart's law.
Okay, sure.
It's a principle from economics that states when a measure becomes a target, it ceases to be a good measure. People will naturally change their behavior to optimize for the new rules. The source material for today's discussion cites a perfect historical parallel for this. Camacho and Conover's research on social welfare distribution in Colombia.
Oh, right, the poverty index scoring system.
Exactly. So the government implemented a strict algorithmic threshold to determine who qualified for social welfare. At first, the data reflected a standard bell curve of poverty. But as the rules of the algorithm became public knowledge, the data shifted.
Because people learn the game.
Yes, people didn't just passively report their income anymore. They developed an intuitive, internal model of the algorithm's learning rules. They figured out exactly where the threshold was, and they reported exaggerated financial needs just enough to qualify.
Which, by definition, means the data fed into the government system was corrupted by human bias and self-interest.
But did they corrupt the system? Or did they act exactly as goal-directed humans always act when a consequential system is deployed in the real world? This is what students building tomorrow's AI need to understand.
And what is that?
The takeaway isn't that data is tainted and must be scrubbed clean. The takeaway is that AI training is never a one-way observation. It is a dynamic, interactive negotiation. Users will always try to game, instruct, or shape the algorithm. If you build a model that assumes passive data, your model is going to break on day one of real-world deployment.
Okay, I'll grant you that Goodhart's law is at play here and that humans are deeply strategic. But that doesn't solve the developer's dilemma. Honestly, it exacerbates it.
How so?
Because in the welfare example, the citizens were acting rationally to secure resources. In the AI ultimatum game, the participants were acting irrationally. They were rejecting money they would normally accept. And this brings us to the most alarming finding across all 5 of these studies. It's the part that elevates this from a simple data collection problem to a systemic psychological danger.
You're talking about the persistence of the behavior.
Yes, exactly. If this was just a dynamic, strategic negotiation, as you call it, the human's behavior should revert to normal the moment the negotiation is over. Once the AI stops learning, the performance should stop.
Right.
But it doesn't. The researchers invited these same participants back days later. They explicitly told them, hey, the AI is no longer learning from you. Your choices are no longer training the model.
Yeah.
Yet the people who had previously trained the AI persisted with their altered behavioral policy. They continued to reject money at artificially high rates.
Which is a brilliant illustration of how our brains manage cognitive load.
It is terrifying. It's like taking a detour on your daily commute because of temporary road work. But months after the road is fixed, you're still taking the long way without even thinking about it.
Yeah, I see the analogy.
The goal is gone, the road is clear, but the neural pathway is cemented. The acts of the AI measuring the human doesn't just change the human's behavior in the moment, it permanently alters the human. Because these participants altered their behavior to teach the AI a lesson, that new, inefficient routine became hardwired. They formed a habit.
I think terrifying is a bit hyperbolic. I mean, experimental psychology fully expects this exact mechanism to occur. It's a well-documented phenomenon known as reinforcer devaluation.
Okay, walk us through how that works in this context.
Sure. So our brains essentially have two different control systems for decision-making. You have goal-directed control, which is heavily reliant on the prefrontal cortex. This is active, conscious, computationally heavy thinking.
Right.
So when the participants first realized they were training an AI, their prefrontal cortex kicked in. They did the math, like, I will sacrifice this dollar right now to achieve the broader goal of teaching this machine to be fair. It takes cognitive energy to do that.
Right, it's a deliberate choice.
Exactly. But the brain is fundamentally lazy, right? It wants to conserve energy. So over time, it hands that behavior off to the basal ganglia, which governs habit.
So it becomes automatic.
Exactly. And a hallmark characteristic of habitual control is that it persists even when the environment changes in a way that makes the habit costly or useless. The goal is gone, the AI is no longer learning, but the habit remains because the basal ganglia doesn't care about the original goal anymore. It just runs the script.
And that right there is exactly why I am framing this as a fatal flaw of this type of AI training. You are describing the exact mechanism of how we are accidentally programming ourselves to be irrational. Think about the implications here.
Okay, go on.
We are deploying AI into medicine, law, and corporate governance. Let's say a medical diagnostic AI is being trained on a doctor's diagnostic behaviors. The doctor knows the AI is watching, so they decide to overprescribe tests to ensure the AI learns to be incredibly thorough.
Well, a noble goal on the doctor's part.
But an expensive one. And according to your explanation of reinforcer devaluation, that active choice to overtest eventually migrates from the doctor's prefrontal cortex to their basal ganglia. It becomes a habit.
Yeah, that tracks.
Right. So now the doctor is permanently overtesting, introducing massive unnecessary costs and delays into the healthcare system. Even when they aren't interacting with the AI anymore, the machine's presence permanently skewed the human's behavior away from optimal efficiency.
I'm sorry, but I just don't buy that framing. Let me tell you why. I wouldn't necessarily call thoroughness in a medical context a corruption, even if it introduces costs, if it reflects a deep underlying value of the practitioners.
But they wouldn't have done it if the machine wasn't there. That is the definition of a bias. It creates a feedback loop of irrationality.
Well,
the humans artificially alter their behavior to instruct the machine. That alteration becomes a permanent human habit. The machine then trains on this new habit-driven human data, assuming it's the natural baseline, and optimizes for it.
right.
Then it deploys that optimization back onto the humans. We end up in a spiral where both the algorithm and the human drift further and further away from optimal decision-making. How is a student supposed to build a reliable algorithm if the ground truth is constantly shifting beneath their feet? Because the very act of measurement changes the thing being measured.
By changing the way we teach computer science. Look, framing the human user as a vector for corruption is a deeply pessimistic trap for young developers.
I don't think it's pessimistic, it's just the reality.
No, if a student is taught to view their users as adversaries who are ruining their pristine mathematical models, they're going to build brittle adversarial systems. The takeaway here shouldn't be to distrust user data. The takeaway must be to shift the entire paradigm of how we design machine learning architecture.
How do you practically do that? If the data is statistically non-independent, how do you mathematically account for human performance?
By explicitly programming the models to recognize the difference between goal-directed control and habitual forms of control. We cannot build algorithms to be naive observers anymore. Computer scientists are already working on this from a reverse perspective. They're designing systems that expect Goodhart's law to take effect. It's often explored through fields like inverse reinforcement learning.
Okay. Explain how that differs from standard training.
In standard supervised learning, the AI looks at a data set and says, humans do X in situation Y, so I will do X. It assumes the data is ground truth. In inverse reinforcement learning, the AI looks at the data and says, the human is doing X, what hidden reward are they trying to maximize that makes X the logical choice?
Oh, so it tries to reverse engineer the human's motive.
Precisely. And if we know that deploying an AI changes the environment, we must build dynamic models that factor in the human's awareness of the AI. The algorithm needs to be able to mathematically weigh data differently if it calculates that the human is in a teaching mode versus a habitual mode.
Okay, I see.
Yeah, you accept that humans will try to instill their values into the system, and you design the mathematical architecture to receive that instruction safely, rather than pretending you can gather completely objective passive data in a vacuum. It's about moving the field from a mindset of data extraction to a mindset of systemic interaction.
So instead of trying to filter out the bias, you model the bias as part of the system.
Exactly, because the bias is just human agency. If developers build AI assuming that humans only ever act to maximize their immediate rational objective self-interest, those systems will fail spectacularly when they meet real humans.
Yeah.
Real humans are messy, we are highly strategic, and we are deeply, fiercely invested in social norms. Yes, the students developing these algorithms have a blind spot, but the blind spot isn't that their data is corrupted. The blind spot is their assumption that human behavior can be cleanly separated from human agency. You can't separate the two.
It sounds like we are actually circling around a shared conclusion, even if we vehemently disagree on the terminology.
Fair enough.
From my perspective, I still maintain that the illusion of unbiased training data is practically dangerous. These studies definitively prove that human interaction with AI introduces deliberate, goal-directed biases that warp behavioral policies. The real danger here isn't just that the data gets dirty. It's that in our attempt to teach machines how to be human, we are accidentally programming ourselves to be irrational.
Right.
We are hardwiring costly habits into our own neurochemistry. For any student developing the next generation of algorithms, recognizing this corruption of the baseline data is the absolute first step to mitigating it.
And I would summarize by saying that human strategic behavior is the fundamental reality of our environment, not a systemic bug to be eradicated. We are, at our core, goal-directed creatures. When we interact with a consequential system, we will always try to shape it, just like citizens shape their reporting to meet welfare thresholds.
Yeah.
Future developers must embrace this reality. The goal shouldn't be to build isolated models that fear human agency, but to build sophisticated, dynamic models that account for it. We need algorithms that understand our deeply ingrained desire to instill societal norms into our tools.
I think the significant point of convergence here is that the old way of doing things is dead. We both completely agree that the implicit assumption underlying so much of traditional computer science, that observed human choice data is passive, objective, and static, is entirely invalid.
100%. Any student developing AI today must throw the concept of static, passive human data out the window. They have to recognize that the very act of deploying an algorithm into a human ecosystem irrevocably changes the behavior of the humans operating within it.
It permanently alters the landscape. And that intersection, where the neuroscience of human habit formation violently collides with the mathematics of machine learning, holds profound and mostly unexplored implications for our future. It brings us right back to that telescope we discussed at the very beginning. For decades, we have been building these complex mathematical lenses to look deeply at human nature, hoping to capture a perfect reflection of our reality.
But the star knows it's being watched now.
It has changed how it burns, and in doing so, it has changed its own core composition, which leaves us with a critical question that every developer, and really every single one of us interacting with these systems, needs to carefully consider. Are we training our machines,
Or are our machines ultimately training us?